We start a new lesson, that is lesson number 12, electricity and circuits. So before going to the lesson, so let me ask you some questions based on this. What is electric current? Where do we use this electric current? At home, where you are using this electric current? So there are different electric devices at your home, right? So we use water pump to draw water. There we are using electric current. Clear? So to light up your house, we are using different types of bulbs. There you are using electricity. To work a mixie, you are using electric current. For the working of TV and refrigerator, you are using electric current. So electricity used to do different tasks in our house. So we are using electricity in different places. And from where do we get this electric current or electricity? From the power stations. Okay, from the power stations, the electric current is carried to your home. And it is not energy that we can use free of cost. We should pay for the electric current. So electricity is a form that we can use for running different electrical devices. Correct? And other than this electric current we use in electricity or we use at home, so can you name some other source of this current? Can you name? Yes, we know that we are having different sources of this. First one, children, there are other different sources which can give electric current. Okay, that is the one source that can provide electric current. That electric current you can use for glowing the bulb or for running different devices. And we call that source as the electric, or this is a battery. Or really this is not a battery, this is a single cell. So this is a source of electric current. This can give you some electric current. So where do we use this cell? Inside a clock, inside a torch, inside a remote control. Okay, so we can use this as the source of electric current. This is a single cell. Even though we are calling this as a battery, that is wrong. This is a single cell. And this is having two terminals. This is the metal cap. You can see a small cap on one side. This is the positive terminal. And the other side, there is a metal disc. And this is flat in shape. And we call this as the negative terminal. A cell is having a positive terminal and a negative terminal. Okay. And this is the pictorial representation of a cell. And we can connect, to get more electric current, we can connect the cells like this. This is the positive of the first cell, this is the negative. This is the positive of the second cell, and this is the negative of the second cell. We can join. Now we call this arrangement as a battery. So battery is having a number of cells connected. Here two cells are connected. We call this arrangement as a battery. So one cell can give a definite amount of current, but when we increase the number of cells, it can give more and more electrical energy. Okay, and we can use this inside a torch or a remote control, or inside a calculator, or transistor radios, cameras, wristwatches, alarm clocks, etc. To provide electric current. So this is also a source of electric current. Okay, children, listen. So this is a cell, a single cell having a positive terminal and a negative terminal, and we can use this inside different devices to make it working. Okay, and what is inside a battery? Did you ever think about the material inside the battery? So some chemicals are packed inside the battery. Some chemical, dry chemical, is closed inside this cell, and that is having some chemical energy. So material inside the cell is having some chemical energy. that chemical energy can be converted into electric current or electric energy. Clear? When we connect this in a circuit or when we connect this with an electric bulb, what happens is the chemical energy inside the cell start converting into electric energy. That electric energy makes the bulb to glow, or it makes the clock to start working, or it helps to light up a torch light, or it helps to work a transistor radio, or it make the alarm clock to work. Okay, so chemical energy of the cell is expanding in all these cases, and electric energy is forming, or electric energy is producing. That electric energy is used to run all these small devices we discussed now. Okay, so this is a cell, and if you want to get more amount of energy, so we need to connect the different cells in contact. This is another cell. Okay, this is the positive of the next cell and this is the negative. Now we call this as this is a battery. Okay, this is a battery. See this closed path of the electric current. Here we use a source of current. This is a cell. So cell, chemical energy stored in it, and this start changing chemical energy into electric energy. That electrons start moving in the circuit. So this is the closed path of the electrons. Okay, or this is the closed path for the electrons to move around, and we call this as a circuit. This is a closed circuit. So current can flow only through the closed circuit. If it is open, so we use some connecting wires to connect all this. This is connecting wire. The positive terminal of the battery is connected to, this is a bulb. This is the pictorial representation of a bulb, filament. This is a filament inside. So, and that is connected with the negative terminal of the battery. So when the circuit is closed, a current can flow through the circuit. And how do the current form? With the help of the chemical energy packed inside the cell is utilizing, or that is converting into, or that is expending its chemical energy to produce electrical energy. That energy can be, or the electrons can move through the closed circuit. We call this as a closed path. And if it is open, now I made this as an open one. This is not closed, but no current will flow through the circuit. So circuit must be closed always to maintain the electric current. Okay, so now this is a closed loop or closed path of the electric current. So current can flow only through the closed path. If it is open, suppose I opened here, so now the circuit is become open, so no current flows. So current flows only through the, so to get a continuous current, we should make the circuit closed. That is a minimum condition for the current flow. So we should have some electrons to flow through the circuit, and we should have a closed path for the movement of the electrons. That is to get continuous current.